Welcome to this week's NORA Startup webinar and the first webinar in this fall of an exciting series of webinars alternating between NORA and NORA Startups webinar. And today it's particularly exciting because we will meet some of NORA Startup members. We will meet a company called Smart Inspection, and we will meet another company called Disputas. They will present themselves and share some of their experience on how to become a successful AI startups. We will look at possibilities, we will look at typical pitfalls to avoid, and we will have a presentation first, and then we'll end the webinar with a discussion between all panelists. And key to this webinar is it is you, the audience, who have the role that ask questions. I have some questions in mind, but if you have something that you're wondering about, this is for you. My name is Morten Gudvin. I'm a professor at the University of Agder, working together with NORA. And NORA Startup is NORA's national innovation network that focuses on research-based innovation and works to facilitate a closer dialogue and collaboration between academia, including students, and startup environments in Norway within AI, machine learning, and robotics. Today, you will meet the two companies I talked about, Smart Inspection, and we will hear from Erik Trædal, who is a CTO, and Halvor Smørvik, who works as an engineer in Smart Inspection. And Smart Inspection is a company that motivates and pushing boundaries of technology. They work a lot with drones, drone technologies, geomatics, and we're very excited to hear about them very, very soon. The other company, Disputas, is working to develop an educational platform for active learning with focus on linguistic analysis and natural language processing. And without further ado, we will like you to invite Erik and Halvor from Smart Inspection to give an introduction. And when they're finished, we will then hear from Paul later on. So Erik and Halvor, are you ready to give a presentation about your company?
Yes, yes we are. So let me start by sharing my screen so we have a little bit background here. So, okay, my name is Erik Trædal. I'm the CTO of a company called Smart Inspection. Together with me today, I have Halvor Smørvik. Maybe you can, yeah, there is. Smart Inspection started a few years ago when drones were new and hip and wasn't widely used. And we started with a philosophy where we wanted to be able to do what others could do with 20 people. We wanted to be able to do with 10 people. And the basis of that is essentially technology. We work in the infrastructure business. And the thing with the infrastructure business is that it uses very little technology. There's plenty of data, but the usage is limited. And based on that, we have two departments. The department that was started first was the Geo department. I see our presentation is in Norwegian. I didn't think about that. Sorry about that. The Geo department is traditional surveying, drone operations, and things like that. And we also do additional information. We do 3D scanning with LiDAR, which is quite exciting. There's a lot of development there where you can use AI to detect objects, 3D objects and things like that. So there's a lot of exciting things happening that we as a company have an advantage with having in-house AI experience compared to our competitors that are more survey-based. We also use different kind of technologies to fetch this data. And this leads into the BIM area, Building Information Modeling, which is essentially how you structure information in infrastructure projects, be it roads, be it buildings and things like that. BIM is how this is structured, and this is the big start on how you can actually use this information in the future. And there's a lot of enablers. we also look at VR and AR and things with this data, but that's the focus. We need to get this data to start with. We do some survey work, create models and things like that. I'm not going to mention that too much. But the BIM part was a kickoff for a big project we had together with Norwegian, the infrastructure owner here in Norway. Norwegian was started as a project where they wanted to do things differently than the traditional way of building roads. And when we started, we got a visit from the leader of the company. At that time, it was Ingrid Hovland. She's now leader of Statens Vegvesen, where she had a small headache with the information. There's a lot of data produced when you produce roads, but a very limited set of this is stored in a way where it can be reused and analyzed, and it's possible to do something in the future with it. So we look at this, we see there's a lot of silos, and our first step there is getting all the data together in a way where we actually can compare it. Yeah, I'm not going into detail, but there's a lot of different ecosystems that don't talk to each other, and there's limited way of exchanging data between these ecosystems. And that leads us to our dev department. We created the dev department a little bit different than other companies. We created it with data science as a basis and programming as a secondary option. And we were lucky enough to get a lot of good AI resources, which we feel is very, very beneficial for us both now and also in the future. And what we did together with Norwegian, we had this project called Innovasjonssamarbeid, where Innovasjon Norge put in some money. We put in money, mostly in part of equipment, processing hours, and Norwegian put in money. And what we did, we created a data platform for storing data from these infrastructure projects. Typical BIM data, there is a big challenge. A lot of this data is in proprietary formats. It's very hard to use. But we think we did very well there. Right now, the project is on hold, but it's most likely picking up both with Norwegian and other actors in the near future. Statens Vegvesen have had a similar project called Saga. Also, this collecting data. All these actors are on the stage where collecting data is more important than doing the analysis yet. They don't have enough data to do any good machine learning. But this platform enables us to do a lot of stuff because, well, it's a platform, it's a big data platform, and we use it to collect data and prepare it for usage for other purposes. The top layer will always be industry specific, but the platform itself will be in bottom. So that's the first part. Our project with Norwegian, we learned a lot. We ended up with a data platform. We spent a lot of hours. There's a challenge with this, but that's how it is. And we're very comfortable what we achieved there. And that leads us to the next project we did, which is more AI related. Probably makes more sense here. And Halvor will help me with this as soon as it shows. There it is. There is a lot of roads being built in Norway, and there's also a big challenge in Norway with something called løsmasser. It's specific for Norway because of the glaciers moving around in Norway. They create what's called quick clay. There's been a lot of writing in the media, especially right after we finished this pre-project. that goes on. How do you know if this ground is stable when you build on it? Be it commercial housing, be it roads or whatever. So we started a project together with an engineering company called Dagfinn Score to try to innovate how we do this analysis. This again, also a project with support from Innovation Norge. We have very good experience with what we get there. You still have to put quite a lot of money in yourself, but it's an enabler. It's a project we would never have started if we didn't get any grant from them. So Dagfinn Score had knowledge about the field. We had some knowledge because of our geo department, but we did the technical part, the AI part. And with this, I let Halvor explain what we actually did in this project.
Yeah, sure. Yeah, so this project is basing itself on trying to make this kind of maps, which I don't know how I could say in English, but yeah, a 3D maps with layers of different kind of soil types and ground types. And there's different ways of collecting data for them, but the one we looked at was where you drill down in the ground, and while measuring the resistance while you drill down, you will get some data back up to the machine. And also I get into it more later, but yeah, you can probably take the next slide, because this is the so here we have left side here, totalsondering, or total sounding as it in English, is a graphical representation of what that looks like. This drilling down, and then you measure like the resistance and how much time you use while drilling down, and also if you put like what they call hammering on, and how much water they use for each, like I think it's 25 centimeters. And then you can compare that with prøvetakning, which is test taking, I guess in English, where they drill down and take a test of the soil type and take it to the lab, and then analyze it to see, is this quick clay, is this soil silt, and stuff like that. And yeah, this last totalsondering we did not touch, but yeah, totalsondering and prøvetakning is at least what we have looked at in our case. I think we can take next. So what can machine learning help to with this process? Yeah. Do you have the image there too? Thank you. So it does usually be like a human type work to try to classify these layers of where should silt be, where should sand be, where should like quick clay be, and so on, based on this kind of graphs. But we tried to combine the test taking and this total sounding with some AI, and I tried to predict these layers instead. So I can go next. Yeah, so let's see. We used 3 different algorithms, or tried 3 different algorithms on this. And
I can move to this one.
Yeah, thank you. Yeah, we used 3 different algorithms. In the end, we decided to try it on 7 classes, which you can see here. It's quite small, but it's like clay and silt and sand and stuff like that, which doesn't really say the whole picture. It's a bit more complicated, but it's like a pre-project, so we tried to at least get some rough layers there. We tried 3 models there: XGBoost, LGBM, and an ensemble model. The best we managed to produce in the F1 with weighted F1 was 0.69, and then we also did some calculation on the gradient of the pressure downwards, because if you have like small grains, then it will be very still when you go down, but if you have like sand, it will go back and forth, back and forth, back and forth. So therefore we calculate a bit of gradient, and yeah, it's a bit complicated at that point. But yeah, that's at least our final score there, 0.69 in the top.
Very good, Halvor. I can take the last part. So what we did there, we did this pre-project. We think the pre-project went well enough and wanted to move on to a full-scale project. But again, the challenge here is money. Data is a little bit changing. Halvor and his team had to work a lot to massage the data to actually be able to use it. And there is quite a lot of data, but maybe not enough for all categories at least. But we applied for a grant from Forskningsrådet because we thought this is something that we should move on. The grant was denied, at least in this round. So this project is actually on hold, but the results were presented to the companies that worked with this kind of data. I can't remember exactly how many were in the presentation, but I think it was around 130 people joining the presentation of this pre-project to start with. So there is a use and need for this in the market. There's a big challenge with getting qualified person to actually do the analysis manually, but there's still quite a lot of work to put this into production. For now, it's money. That's the main challenge for this part. But I think the concept is good, and it's one of the things we might pick up if we have the funds to continue on this. And that's pretty much all I wanted to present about us for this time. We probably will have opportunity to talk in the future. And it's always possible to ask us questions on or chat the meeting here and afterwards in.
So thank you. We will of course have you back in the chat in the discussion later on. But an immediate question that comes to me is. How much time do you spend on the data massaging, data analysis part, and how much in this large project do you spend on the actual algorithm development? Of course, as a machine learning person, the exciting part is to develop the algorithms, but I spend more and more time on the actual data cleaning. So do you have an estimate, like how much percentage would you spend on cleaning the data and how much on algorithm development?
Halvor, do you have an estimate? I can't remember.
Yeah, that's... it's probably like 80-20 or something like that.
Okay.
Maybe 70-30.
Oh, it's not that bad. I think most I've heard is like 90-10.
Yeah.
Okay. So thank you. Very exciting company and very exciting presentation. We will welcome you back in 15 minutes because now we're going to hear from Paul talk about Disputas. And as we mentioned a couple of minutes ago, the idea with Disputas is a learning platform that kind of works differently than what we had now because it's more about natural language processing, etc. So Paul, what can you tell us about Disputas?
Yeah, so first off, I should just say that it's really good that you guys just talked about data and data cleaning, because I guess the basis for our project is also a concern with the data, in our case for natural language processing. But yeah, I'll just jump into it. So yeah, my name is Paul. I'm from Disputas. We are an edtech and NLP company at the same time. And in what follows, I want to tell our story and give a brief introduction of our core ideas. We got started about a year ago. Anders, Andreas, and I were the founders. And our project sprang out of Anders' work in his master's degree in language technology from the University of Oslo. In his thesis, Anders trained an algorithm to detect logical inferences in text. And as with most tasks in NLP, the training process required a large amount of data, and that data needed to be labeled in a very specific way. This often leads to researchers spending a lot of time analyzing text, and this is what Anders ended up doing as well. Moreover, paying others is costly since the theory is complex and requires expertise, and this often stifles projects in NLP. My background is in the humanities, and when I was studying there, I too spent a lot of time analyzing texts in much the same way that Anders did for his thesis. Only I did it using pen and paper or outdated technologies. After finishing my master's in philosophy at the University of Bergen, I started studying language technology at UIO, and there I met Anders. And when we got talking about how to solve the biggest problems in NLP, we agreed that the biggest bottleneck was data, and good data, large amounts of it. And then we started talking about the similarities in the work that humanities students do when they analyze texts, and also the annotation work that is done by NLP researchers. So we realized that educational programs for text analysis and also programs for text annotation and NLP are almost entirely identical. The main difference, it seems, is that people pay to use the educational programs, whereas people are paid to use the annotation programs, even though the users analyze the text much the same ways. So this realization was the basis for our idea that through educational technologies for text analysis, student efforts can be collected as data of the exact kind needed to develop corpora for high-level concepts. So this idea we thought was really good. So we partnered with Andreas, who has a background in robotics and cybernetics at NTNU, and also industry experience with web development. And we applied for funding first from Inventu through a competition they hold called the Inventu Start. And we won that, and they helped us establish the company, Disputas, and get things going. Then we also applied to this scheme from Forskningsrådet called Student Forny, and also SkatteFUNN, and received extensive support, and this got our project really started. We are also supported by grants from DOGA, Innovation Norway, and the Center for Effective Altruism, and are currently incubated at the Simula Garage at Oslo Met. These actors made it possible for us to develop an MVP of Ponder, which is the platform for text analysis that I'm now going to present. Yeah, so now I want to shift from talking about the origin story of our company to talking about the main product that we work on right now. And also after that, I want to say something more about NLP products that we want to develop at some point. So the problem that educational programs for text analysis try to solve is, well, mainly that traditional education can be kind of boring, especially in text-centered courses. Students passively read and listen to lectures in solitude. They typically won't get any feedback until exams, and that is often too late. For many students, learning becomes a chore, and many struggle to complete courses, and institutions suffer attrition. Also, the effects of traditional courses on test scores are unimpressive. Okay. Most researchers that have studied this agree that the solution is active learning. Active learning is practice-oriented and collaborative. Students get to test their understanding through practice assignments and with others. Software is often used to facilitate for collaboration and practice. Both students and teachers enjoy active learning, which is also demonstrated to be several times more effective than the traditional approach. Because of this, Norwegian and the international ministries and departments actively support active learning initiatives. Despite the wide success of active learning in many areas of study, analytic language-based courses like logic, linguistics, and law are almost entirely unsaturated. So this is the background for our project, which is to develop Ponder. So the way Ponder works is a student uploads a text to be analyzed. The student then marks parts of text, assigns labels to these linguistic units, and relate them to each other in structures that reveal the abstract patterns that exist in the text before. So The first module that we've been working on is a module that targets argument analysis, which is the form of analysis that Anders was doing for his master's, and also the kind of analysis that students of critical thinking courses work on. I myself personally know many of the educators seeing the relevant courses in Bergen, and many of these teachers are my friends. And these have been essential for developing the design of the platform. Yeah, many studies indicate that courses using programs of this sort consistently gain up to 4 times improved test scores compared to courses using traditional methods. And we actually did a literature review looking into the literature on this that we summarized in an article that is currently pending review for a peer-reviewed journal. So even though the platform right now is centered on critical thinking and argumentation, the design for the platform itself is quite general and can be used in most, for many use cases. And we're right now looking into law. Here is a sketch of how we think that the platform can be used for practical assignments, doing praktikumsoppgaver, which is like the kind of the main task that law students deliver and get graded on. Yeah, it is also worth repeating that Ponder is designed to generate a special form of data through interaction. And so there is no AI in the platform itself, in the learning platform, that is. It's students do everything manually, and teachers have to read or look through their assignments manually. But if they do it, and if we can develop the platform in a way so that it's applicable and serves this pedagogical need, then interaction with the platform generates the exact kind of data that is needed to train AI systems the same skills students learn through these courses. And so our long-term vision is to transform the educational sector into a data collection research infrastructure for NLP research. And to do this for all courses, text courses, where the program or a similar, or like an extension of program is applicable. And so what kind of company are we then? We work mainly on this educational platform. This is our core project. But if and when we develop it so that it's useful to educators and students, we will start working with the data as well. And we have several ideas for how we can use data that exploits the structure of the Ponder dataset. But there are especially 2 ideas that we've been thinking about the past 2 years that we think is especially worthwhile exploring. So I'll just go quickly through these. The first of them is HILES, and this is an extension of Anders's MA thesis. And the HILES is an intelligent AI assistant for critical literacy and persuasive writing. The idea here is to develop a product that is similar to grammar checking services, only that it corrects the logic and writing of the author instead. There are several unique differentiating features of HILES, and the way to think about this is to think what kind of university courses is Ponder applicable to, and what kinds of things will students be marking and analyzing and finding in these texts, in these courses. And then this should inform how HILES will look like in the end. So if we only think about courses in critical thinking, then the main focus there is arguments and logical and other fallacies. Also rhetorical figures and misleading language, vague and ambiguous language too, is very, very important. And so if students use this program in these courses, then we can train HILES to discover and to detect and expose arguments and fallacies in texts that a person will be reading, and also these other linguistic structures. And it could do the same thing also for writing, so it can make you a better writer as well. We also think that something like this can be very useful for giving a structured summary that exposes these linguistic structures. The other idea that I want to briefly mention is how this would look like in the case of law, which is where our efforts, or at least our design efforts, are currently being directed. So we think that we can train an algorithm with legal data that also is structured in this inferential manner. And with this, we can exploit this this model, we think, to create a function for legal source search. And the important thing here is that that a user can search with descriptions of a case that non-jurists would use. So if you try to search in like a legal source library right now, for instance, law data, you have to use these search words, and you have to basically know what juridical terms you should use in order to get relevant legal sources. We think that with good enough data sets, we could replace this with something more resembles like the searches that you see in Google. That is more flexible, and that could be actually used by non-jurists as well. The other thing that the other function that we have been thinking about concerns prediction. Here we envisage a system that gives quantitative estimates for the likelihood of the most probable outcomes of a legal issue. As of 2020, there are no good legal judgment prediction systems that can explain the reasoning behind their judgments, which makes these programs unreliable for serious juridical work. We think that the unique inferential structure of the Ponder dataset gives the structure needed to train a predictive model that can explain its reasoning, or at least mention the salient relevant legal consideration that bear on the judgment. So the thinking here is that since Ponder is structured inferentially, or the Ponder dataset is structured by inferences, that's what the arrows are for. If a user marks, for instance, legal judgment and finds the legal sources that bear on the rule of law that should be applied to the facts of a case in order to establish a juridical decision or judgment, then those arrows, the way that they point, actually gives the system the data that it needs to explain why the conclusion should be as it is. And so this makes it possible to justify, for a system like this, to justify its conclusions. These were the things that I wanted to go through. Our team consists of a bunch of students and former students, most of which are from the language technology department at the UIO, and others from NTNU. And you also have an extensive design team. I should mention that most of us work part-time, but you have two working full-time right now. So yeah, that's it. Thank you.
So thank you, Paul. Another great and exciting company. A question that immediately comes to me is, it seems that natural language processing is central to your product. How much are you reliant on existing tools, libraries for natural language processing? How much are you developing yourself? We know that BERT and these type of models are very, very well known for language. Are you depending on those, or are you making something completely from yourself?
Good. Yeah. So yeah, we are entirely dependent on those. For many of these tasks, which concern finding structure in that are like pragmatic sense going across entire paragraphs, it's absolutely necessary to use these big language models and fine-tune them just with the data that we have. But just fine-tuning these models requires quite large data sets because the tasks are so complex.
Great. I'd like to ask Erik and potentially Halvor back so we can have a discussion, everyone. And I think I'll start out by asking, because both of you talked about the difference between or getting funding from Innovation Norge, from Research Council of Norway, and maybe we can start by Paul. So how important do you think those type of finances are compared to other investments you come from, personal investments, etc.? So how crucial was that to your build-up of your company?
I think we of course believe in our idea and would most probably work on it part-time all our lives if we didn't get any funding. So but when it comes to speed and it's been absolutely essential that we got support from the Norwegian Research Council and Innovation Norway. At least for us, the student grant has absolutely catapulted things for us and made things go a lot faster than we could otherwise have gone.
And what about you, Erik? I guess is the one answering the question. So how fundamental is this type of national funding, non-private funding?
I mentioned two projects. One was the Smart Lake project together with Nye Veier. That is a project that might have been done only with funding from us and Nye Veier. I say might because I'm not certain if we would have started it. The ground drilling project had too many uncertainties, and without funding from Innovation Norway, that would most likely not have been started. So this support in our cases, there is a chance that in both cases that would be a make or break for us. The uncertainties are very often too large to be able to put enough money, and you have to account for that it takes quite a lot of effort to test these theories.
Absolutely. So it amazes me that I think every company we've had through the NORA webinar gives the same answer. It's always like the national funding kind of pushes you a certain way. So that's a feedback to the both Innovation Norway and Research Council, I think. So let's go a bit more into some of the details. There's been some questions for you, Paul, and I will ask some of them. So how do you handle non-digital educational resources? You talked about NLP, and assumingly it's mostly digital. Do you at all handle all the speaking I do as a teacher that is not digital? Is that in your area or at all?
No, we haven't really thought about it. I guess one could translate or use speech to text and things like that to do the same things but we haven't really been thinking about it.
So just a wild idea would be you're talking about logical fallacies, for example, and whenever we hear a political discussion, we get these all the time. So it's kind of like a bling, the chess arrow that goes back and forth, like fallacy there. So that would be a
that would be great. Also, you could also envisage our model scanning through everything that a politician has written, and then finding all the fallacies that the politician has used, and saying something like, "Oh, this politician uses the ad hominem fallacy 14 times more often than these other politicians," and things like that.
And then you have to think about scalability, because that's a huge task, I think, because it will go completely red, right?
Mm-hmm.
I think logical fallacies are one of the things that we see often in the political. So I'm partly joking here, but it's good. And if you take this question a little bit further to you, Smart Inspection, how do you handle data that is not necessarily the data that you consider? We talked about, for example, drilling. There's a lot of data that comes from drilling experts, I says, but I would guess that sometimes it's not as you expect. Is that a big problem for you?
Yeah, for the drilling, it's always a big problem, but for the drilling, it kind of relies on person running the machines manually and things like that. So there will be a lot of dirty data, and it's a challenge to know which data to use and how to use it. For infrastructure, it's probably even worse because there will be different kind of structure on the data all the time. And during maintenance of the infrastructure is when most data is produced, and one building produces data in a totally different format than the other. So it's a very, very big challenge that the platform tries to solve as best as it can.
Mm-hmm. And if I understood you correctly, that is kind of the idea with the first project, to add a lot of the data together so that it's more like understandable, kind of like a data lake that is more.
Yeah. It is a data lake. It was called Smart Lake based off that, but we did rebrand it to a meta because it's pretty much more than a data lake, and it was a little bit wrong that people expected it only to be a data lake.
Right. And I know from the NLP world, there's a lot of public data that is available. But is there any international open source rock mass data sets that you can use? Or is there any international effort applicable to the Norwegian geology at all?
Not as far as I know. There is some research on rock by itself. A lot of places they have rock, but this combination between different kinds of clay, rock, gravel, there were very limited amount of research that we could rely on.
And I'm guessing, and correct me if I'm wrong, that much of this is private companies that don't necessarily want to share their drilling approach. Is that correct? Or
yeah, maybe to some extent, but this drilling data is usually owned by the infrastructure owner. So in Norway, it will be Statens vegvesen and these big actors that actually have shared. But the way it's drilled is specific for Norway and maybe Sweden. So it's hard to use data for other countries, like how you run the drill and things like that.
Okay, so and I guess for your, if I understand you also, you have a high F1 score, high accuracy, but I guess there is certain types of rocks that are more important to detect than others. Is that so? If something is falling down the mountain, I'm more concerned about that than not falling.
Yeah. So the most important one was quickly by far, because we have big areas in I think it was Østlandet and also around Trondheim and Trøndelag, which just stands on quickly. So it's pretty important to find those and try to predict if there actually is there or not.
Sure. And since you are computer scientists, I think, and then how do you work with that, with the expert knowledge that comes from these type of rock people that work out there? Is it hard to talk to them? Or?
I mean, it's like there was some communication problems with what a label is. And yeah, the data also had a bunch of labels around them, so it's a lot of work was done for, as we said earlier, on this massaging the data, right, and try to find a way we could predict it with the expert knowledge of them in mind.
And how do you see that area, Paul? You talk to obvious experts. I understand part of them are part of your company that knows about logical approaches, but you said you talked to your previous professors, etc. So is there a lot of, how challenging is it to collaborate interdisciplinary as your company is?
It's not been really much of a challenge for us. So I guess for us, the biggest challenge having to do with I guess the theoretical side of things is that different universities use different textbooks, and they sometimes they use slightly different notation. But at least for informal logic, which has been our focus up until now, the theory is at least like the core of the theory is much the same. You have like logic is the same in every language, and the same, and the fallacies too are almost always the same. So we've been focusing on the English also, which makes it even easier. So there have been only very slight difficulties with some I guess notations that different universities use. Yeah, it's quite general. It's harder in law, so there we we'll probably have a much harder time, but also the commercial upside, if we can get data like this, is much greater, so we think it's probably worth it.
Why is it harder in law? For me, law seems more structured. I've never actually read a law, but I think that's how I look at it. Shouldn't it be easier? Or
so law, like in itself, in the theory, is like perfect for NLP, but the problem is that the different countries has different laws, so there are also like different I guess law systems. So there will be like small differences between all the cases. So you probably have to train the algorithm like for each country specifically. And on the different data sets, because legal practice and the law is always different. So that's that's like the big downside.
And I guess the implication of doing something wrong is much greater, I would expect, in law than for students. Is that true?
Yeah, that as well. But still, just having like a I guess a prediction machine or like a system that can help you think about these things and give you quantitative estimates for how likely it is that courses that cases will go this or that way will be also be useful for jurists. I guess the key thing is you should never like trust an AI system in law, but you could like follow its reasoning, and that could be like a help.
Right. And how do you deal with the human laziness in that sense? Because we know from systems such as in Google Maps, for example, that people drive off the road because Google Maps says so. And I would expect a law system to be similar. So even though it's a smart judge or a smart jurist, he or she would at some point trust your system because it's very good, and then even trust it when it doesn't work. Have you given that any thoughts?
No, that's a problem for when our system is so good that people will like stop doing their jobs because of it. But yeah, we do hope that systems like this can at least be used to automate like the most boring parts of legal work that's being done with like case processors in NAV and other like I guess kinds of work that don't really require very extensive like thinking on part of the jurist, but it's like easily automated by a machine.
Good. And have you ever planned to use the Ponder system for scientific literature, even the archive or PubMed or something like that? I'm guessing there's a lot of logical fallacies and other logical issues there.
Oh yeah, well this is our dream. So we think that we can extend the Ponder system for research as well. So right now it's mostly about marking parts of text and like building a representation of the structure of the argument in a text. And this is good for pedagogical purposes, but our long-term like dream, I guess, is to put in functions that lets the user estimate how likely they think it is that the key propositions in the text are true, and also how strong they think the inferences are. And this can actually be useful for research purposes, because at least for long chains of reasoning, it can be quite hard to like keep all the relevant considerations in place at the same time, especially if you take like multiple articles and even entire books. And so creating like a knowledge graph that's structured logically, that would be like I guess the ultimate extension of Ponder for research.
And I guess part of that would kind of be the interpretable way, because I guess legal system, let's say, or even a teacher system, something would probably say, fine, you do that, but I wouldn't like to know exactly why you claim my paper to be that. Is that something you think about, or?
Yes. That's exactly the thinking, that doing it this way will actually I guess record how the machine will be thinking, because its inferences will follow like the same forms of inferences that humans make, and that is something we can understand.
Is that something that you feel at home with, Eric, perhaps? Because I'm assuming again that the geologists that want to use your system want to know how the AI actually does the prediction. I saw that some of the algorithms you mentioned were not in the deep learning world, but more like more interpretable decision tree, this type of thing. Is that deliberate because you want interpretability part of it, or is it those that were most readily available in the library use?
Yeah, to start with, it would be a support in defining the layers in the ground, and if possible, we would want algorithms that we can actually interpret and reason why it has made these choices. The basis is that there are too few geologists in Norway and too much building. So in the near future, it will not be possible to do this analysis manually. But it's a support tool, not something we would totally automate.
Exactly. And have you ever tried to estimate how much time you save or how much time a geologist will save using such a system versus doing it manually?
Yes, but I can't remember the numbers right now. Do you remember it, Halvor? No.
No, but it's considerable.
Yeah, it's considerable, and it's time they could spend on being out in the field and doing things that are a lot harder to automate.
Mm-hmm. And what about you, Paul? Have you ever done any estimate on the man hours saved, either from a teacher or from a legal perspective, or any that type of area?
No, not really. Only like intuitive estimations. But we do have some jurists on our team, and we're also we have many friends studied law and are currently working as jurists. And for many of there are quite many tasks that a robot could automate that jurists spend a lot of time working on, and most of them concern search for legal sources, and so yeah, we're quite confident that it could be quite many hours.
And much of your work has to, or someone has to do some sort of annotation or some sort of manual work on labeling this. Have you ever thought about sharing that type of data, or is that core to your business? How are you thinking about the data that you have as training purposes?
Yeah, good. So I guess in an ideal world, we share Ponder for free to everyone, and also we give data for free to all researchers, and we I guess use these data sets. Perhaps we just keep like a small percentage of it away for ourselves, and then we use these to create the programs that we are most enthusiastic about ourselves. And since we just keep a small run to it, we can always be ahead on at least those programs. That would be like the ideal case, but that only works out if we can manage to make these NLP systems operative, and they actually are commercially viable and will survive. Otherwise, I think we would have to find some way to commercialize both Ponder and the datasets if we have to, even though we don't want to. But we could always, of course, be open to signing contracts with the researchers and others that specify that they can use data for specific purposes, as long as they don't give it away for free to everyone, and don't make competing products that also is just given out.
You keep saying ideal world, and of course we want to want an ideal world, but is it a realistic world to think this way, or is commercialization of the product the most realistic path?
Well, I definitely think so. So yeah, we are confident, but I don't want to make any promises. So
of course, we won't keep you to those. I think you talked a lot in your presentation about collaboration with previous professors, I think. So how is this working in practice? So do you have meetings with them every week? Do you propose master thesis projects, or what does that mean in practice, really?
Okay, good. So in the beginning, we didn't have very much close collaboration. We spent a lot of time reading textbooks for the relevant courses, and we had a few meetings here and there to say something about what we had been thinking and show some designs and earlier prototypes. And then as the program has been more fully developed, we've been increasing the intensity of meetings. So now this week, I probably had something like 7 or 8 meetings with the educators that have been testing the program and are giving feedback on things that we can fix and things that can be improved, features that it would be good to implement, and things like that.
But do you see those educators more as customers or like collaborators, or both maybe? I'd
rather think of them more as collaborators. They're like so in our design group, we have a designer, and also we have I guess we call them fagkonsulenter, which is like I guess researchers that knows the literature and things like that. And we together design how the platform is to work, because it has to be informed by the the cutting edge of the theory that's being taught at universities. So I guess I kind of think of educators that are involved as an extension of our design team.
Erik and Halvard, how is that in your company? How much do you think back to your university days and collaboration? Do you have bachelor projects, master projects, that type of thing?
Sadly, not enough. It's something we had a challenge with having enough man hours. And what I think is, if we are going to bring in students as researchers, it's very important that we have capacity to follow up and help and support them. The previous year, we've grown quite a lot last year. And the previous year, I didn't feel the capacity was there, but it's something we are looking at models and how we can actually accomplish.
And yes, and can you think of students as maybe half-year job interview, or are you thinking of them more like a resource that you have readily available for some time?
It could be both ways. As a resource, of course, especially in machine learning, students are on the cutting edge. We don't have, it's not possible for us to have people doing AI full time. So that as research, especially for the AI part, is important. But it will also be a place to see who performs well, who do we have good chemistry with, and things like that.
And are you, both of you, are you open to applications, meaning like sending to Research Council of Norway, this type of thing, together with academia? Let's start with Sarkod first. Is that something that you think about? So applying for funding together with academia is a question from the audience.
To me or to Smart Inspection?
Smart Inspection, sorry, Smart Inspection.
Okay, yeah, that's definitely something we have thought about. We have good relations with the UI and plan on improving those relations, and sending together with academia would probably be beneficial for us in very many cases. It's been mentioned once or twice, but it's not cultivated to anything this far.
What about you, Paul? I think you mentioned some of them in your proposal even. You plan more applications together with academia?
Yeah, I guess. So yeah, we did send an application for the previous round in February with some leaders internationally in in argument mining, and also with the researchers from Norway. Then yeah, in various fields, both in machine learning, but also on the theoretical linguistic side of things. So I guess we're very open to projects of this sort.
I guess many of your listeners will be happy for that. So last question for both of you before we round off, a couple of minutes too late, I think, but still. So how do you think, what would be the ideal place for NORA and NORA.startup for you? If you look 5 years ahead, how can NORA.startup be like the perfect situation for you in any way? So Paul, what would NORA.startup be ideally?
So to me, it would be a good way to, I guess, learn to know what their machine learning researchers care about and want to do, especially in the field of NLP in Norway. We aim to create something like a research infrastructure that collects the data that's needed to do a range of interesting things. I think that the idea is quite general and that we can extend the platform in various ways. And so it's important for us that we understand how the data can be used and what's good uses of the data. And we can try to design the platform to generate data of that exact kind.
What about you, Erik? I'm cutting you short because we're running out of time. So Erik, what would be the ideal place for NORA.startup in your daily life? Yeah,
we're not that big, so it's very important for us to learn from other startups what they do, where they fail, where they succeed. Learning from others is also always a lot cheaper than doing your own mistakes. And also it's important for us to have have an environment where our AI researchers can expand their knowledge and don't get stuck in working life and only know what they learned in university maybe 5 years ago.
Perfect. Very good ending. So we would then like to thank Smart Inspection with Erik Trædal and Halvor Smørvik, and Disputas with Paul Kvarberg for this exciting webinar. And we ask, of course, all of you to tune back in to the webinar in 2 weeks, where we will talk about law. We've already touched upon law here and law and innovation. And we will also have the 26th of August, we will have a collaboration with Innovation Norway about funding possibilities and collaboration possibilities. So for all of this, you can go to the NORA website or the NORA.startup website, or you can send an email to any of us here and we will guide you. See you all in 2 weeks' time.